So today we're going to be working on the focus in the directrix by creating an equation in what we're going to call focus form. And now focus form is a slightly misleading phrase because I'm going to make this equation in y equals a x minus h squared plus k, which is vertex form. But I'm going to make it in vertex form using only the terms of the focus. So my a, my b, and my directrix, which we're going to refer to as y, is equal to d. So let's go ahead and we're going to create a proof that's going to give us a way to do this that's going to be a lot faster. Now, we can derive this process that we're about to show right here on every single problem, but again, it's a rather lengthy solution to create an equation. What I think would be a better course of action is let's work with the actual just generic focus form, create an equation for ourselves so that we can just plug in the information and solve it. So let's take a look at what exactly is a parabola in context of focus form. So I'm going to draw my parabola like this. Now this parabola isn't necessarily drawn to scale. So like when I draw my vertex, or not my vertex, my focus right here, that's not necessarily equidistant from each one of these in comparison to my directrix. So again, it's just a sketch is really what we're going for here. So this is my directrix. So this is going to be under the form of y is equal to d, d for directrix. Typically the focus is going to be in the form of a comma b. And so what we know is that every point on this parabola, let me pick a point that actually looks like it's about equidistant. I know that point on the parabola, the distance between this and the distance between this should be congruent. So I'm going to draw my tick marks and say that those should be equal at every point along this parabola. And now this point right here is going to be the generic x comma y. That allows us to move it anywhere on the parabola. If I want to move it over here, I could. If I want to move it up here, we could. So far I have a generic focus, a generic point, and a generic discriminant. So what I know is the fact that I need to be able to relate these two to each other. So if I can create a formula that makes this distance equal to this distance, I'm good. I can rearrange that into my vertex form. So let's set up an equation for what is this distance? Well, this distance, the x doesn't matter because it's a vertical line. In fact, if I wanted to, I could draw a little right angle mark. So I know there's no horizontal distance. It's simply vertical. And I know that the distance right there is going to be however much the height is. It's going to be the full length of y. So I'm going to go all the way up, but I'm going to take away the distance down here. So it's going to be y minus d. I'm going to take the full length, which is this full length right here, and I'm going to remove the part of the length that's below the directrix, which is going to leave me with just this red line. Now, there's an off chance, let's say, that that distance is going to be over the axis, or maybe it's flipped upside down to where I could get a negative distance, which would be a negative length. We don't want that. We want the distance to be positive at all times. So the way that we're going to get around that in this is we're going to do something. We're going to square it and then square root it. So that way, for example, if this was a -2 distance, -2 squared is going to be a 4. The square root is now +2. And that's just a little bit of technical algebra there that's going to make our lives a lot easier to where it's always positive. Even if we have a somehow mathematically negative distance, depending on where this is, boom, we made it positive. Second thing we're going to look at is right here. I need the distance between 2 points. I know that goes back to basic geometry. What I can do with this is I can create a right triangle and say, hey, I know the distance of this triangle is going to be a squared plus b squared is c squared. And that distance is the square root of those distances. So I know that the distance for b is going to be the differences between y and b, y1 and y2. So I'm going to say this is equal to the distance of, actually, I'm going to do that in this bracket. So I have the distance between this y and this b. So y minus b. And because it's b squared probably should have drawn that as a capital B, so that way it's a different, and that's going to be a capital A. That way it doesn't get confused with our focus of B. So I know it's y minus b squared is going to give me b squared. For my a, I'm going to have to look at the x's. So x1 minus x2, or in this case, x minus a. I know it's a squared, so I'm going to square it. And then to get that, I'm going to square root this entire side. And now this is what I'm going to work with right here, is I have everything I need to create this equation. So let's take a look at this. First off, I'm going to need to get rid of these square roots. So my first step is to go ahead and square both sides of the equation. And what that does is that frees me up to do some other work. So I have y minus d squared is equal to x minus a squared plus y minus b squared. And so what I know is that I'm going to want to isolate my y, which means that I'm going to need to actually FOIL this out and FOIL this out. Because there's no y in here, I'm going to leave this. And then conveniently, we can notice that my x minus a squared looks a heck of a lot like my x minus h squared. So I'm probably just going to leave that throughout the entire thing. But in order to isolate my y, I need to go ahead and square this and this to get rid of them, or to get rid of the parentheses. So if I square this according to my rules, I know that that's going to be a y squared minus 2 dy plus d squared. I'm going to leave this x minus a, and I'm going to square this over here. So I'm going to have a y squared minus 2by plus b squared. Perfect. And so now my next step is to move all my y's to my left-hand side. So what I'm going to do is I'm going to subtract this y squared, which conveniently just cancels them out. And then I'm going to add this 2by to move that over here. So add 2by. And then because y is the only thing on this side of the equation, at the same time what I'm going to do is going to move anything that doesn't have a y away. So I'm going to go ahead and subtract the d squared, which is going to move that away from this side. So now let's see what I have left. On this side I have a 2by minus 2dy, so far so good, equals, I have an x minus a squared, and then I have a b squared minus d squared. And so I know I need to factor out the y. I also notice they have a common factor of 2, so I'm going to split this up into two different things. I'm going to factor out my y, which means I'm going to have a y. I'm also going to factor out my 2 separately. So I have a y, 2, and I have a b minus d is equal to x minus a squared b minus d. So what I notice here is that this is a difference of squares, which means that I can split that up into a b minus d times b plus d, and that factors out, which allows me to do this. Now in order to get rid of everything attached to the y, I'm going to go ahead and I'm going to divide this by a 2, b minus d, and it's going to cancel all of this out. That means I need to divide both of these by a 2, b minus d, and a 2, b minus d. And conveniently what that does is what we noticed is that my b minus d's are also going to cancel out over there. And what we're left with is we're left with the formula in vertex form. So I only have my y over here. I have my x minus h squared is my x minus a. I'm going to shift this out to the side. So I'm going to say that's a 1 over 2 b minus d times x minus a squared. So that's the same thing. All I did was I moved that bottom part of the fraction over so that I can recognize that that's going to be my a. And then over here I have a b plus d all over 2. And what this has allowed me to do is it has allowed me to say, hey, I can compare these two functions. To get my A, I can calculate 1 over 2 times B minus D. To get my H, that's just the value for A. And to get my K is going to be this thing over here. And so I have a formula of a quadratic in vertex form using only the focus and the directrix. So let's go ahead and see how quickly this will work. As opposed to having to do this process every single time, we've created ourselves a little cheat sheet on how we can just knock this thing out. So let's take a look. What I'm going to do is I'm going to take my focus, my directrix, that's my A and my B, and that's my D. I'm going to plug it into my formula of 1 over 2 times, let's see, my B is 1, minus my D of negative 1, so minus a negative 1. And then it's going to be, okay, x minus my A, which is 0, squared, plus, let's see, I have B, which is 1, plus D, so plus a negative 1, all divided by 2. Kind of squishing that in there, but that'll work. So let's go ahead and simplify this. I notice that minus a negative is going to turn into plus a positive. So that's going to be 1 plus 1, which is 2. 2 times 2 is 4. So I have y equals 1/4. X minus 0 is just going to be x. 1 minus a negative 1 is going to be 0. 0 divided by 2 is going to be 0, of which we don't actually need to write, so I'm just not going to write it. My equation then, therefore, is this. And if I wanted to graph that, it'd be super easy. Let's just go ahead and put our focus of 0, 1. Let's put our directrix of y equals negative 1. Let's find 2 points along this line where I can graph this thing. I know that via this, my vertex is at 0, 0. I could have also visually looked at that, but I've now mathematically proven that it's going to be at 0, 0. Again, because the distances are the same. I also have a point right out here where the distances are 2 and 2. So I'm going to put a point right there. And I'm just going to curve up through that. Boom. And there we go. So we see how this took a ton of time off having to do this every single time. We're able to, now that we've derived a formula, plug it in and solve it in one step. So let's do that one more time to make sure we got it. So what I need to do is I need to use our handy dandy formula, and I'm going to plug in my information. So I have 1 over 2 times, let's see, this is going to be a B minus a D. So my B is negative 2, my D is negative 4. I'm going to multiply that times x minus my A squared, and my A this time is 0 again. And to it, I'm going to add a B plus D all over 2. My B is going to be a negative 2. My D is going to be a negative 4. And so let's simplify this. I have minus a negative, which means that's plus a positive. Negative 2 plus 4 is going to be positive 2. Times 2 is 4, so y equals 1/4. X minus 0, that goes away, so it's just x squared. See, negative 2 plus a negative 4, so that's negative 2 minus 4, that's negative 6. Negative 6 divided by 2 is going to be negative 3. And so looking at this, I'm going to expect my vertex to be at 0, negative 3. And let's see if, in fact, if I graph these two, if that's going to be directly between them. So my focus is at 0, negative 2, and my directrix is going to be at negative 4, which, lo and behold, yes, it is directly between those points. And so it's directly between. I noticed that over here and over here, I also have a point that's exactly 2 units away from both my focus and my directrix, So I'm going to curve up through those points. And boom, there we go. So we see the process works really quickly once we've derived a formula for us, but I think it's very important that not just here's a formula, memorize it, but that we recognize where that came from. It's literally just two distances set equal to each other, and if we wanted to, we could work all of that each time. But again, I think it's important that we know how to do it just on our own. So this time the focus is going to be moved over, which means also I'm expecting my vertex to be moved over. As with this one, I'm expecting the vertex to be moved over along with the focus. So go ahead, pause the video, try these two problems, and when you're done, resume the video and see how well you did. And I might be able to answer any questions as we go through. Okay, so let's take a look at what we can do. So with this, if I were to plot this, I would plot my focus at 3, 2, and I would put my directrix at 0, which means I'm expecting to get an H and a K that's equivalent to a 3 and a 1. So I could kind of cheat and go ahead and plug in a 3 and a 1 for that equation and only have to figure out what the A is. But for the first one, I'm going to go ahead and I'm going to work it the long way. So what I'm going to do is I'm going to say, okay, y equals 1 over 2 times b minus d, x minus a, plus b plus d all over 2. So I have a b minus d, a, and I have a b plus d all over 2. So remember, we are expecting to get a 3, 1, so I'm expecting to get a 3 right here, and I'm expecting to get a 1 right here. So again, I don't actually need to do these parts. All I'm really focused on is the a. So y is equal to 1 over 2 minus 0 is 0, or 2. 2 times 2 is 4. I have an x minus 3 squared, and then 2 plus 0 is 2. Divided by 2 is 1, exactly like what we expected it to be. So I have that. Again, I have this cheaty point that I can use that's exactly 2 and 2 away that allows me to kind of curve up through those points. Perfect. So knowing that we have kind of a cheaty method right here, and all we really need to do is find a, what I'm going to do now is I'm going to go ahead and not fill out the entire formula. I'm just going to fill out the part for a. So I know that a is equal to 1 over 2 times b minus d. That's really the only part that I need to calculate out of that. Outside of that, I can just kind of visually look and say, there's my vertex. So if my a is equal to 1 over 2 times 5.5 minus 4.5, see 5.5 minus 4.5, that's 1 times 2, that's going to be 1/2. So let's see if I can't use that information to skip having to calculate all of this. So I have a focus at, I'm going to have to scale this one back. So I'm going to do this by 2's, I'm going to do this by 2's. So at 2, 4, 5, 2, 4, 5.5, and so 2, 4.5. Awesome. So I know I have those 2 points. And then to find my vertex, I'm just going to find what is exactly between 4.5 and 5.5. That's right, 5. It's actually a little lower. So I'm just going to make my point a little bigger to kind of hide that. So if that's at 5, the focus has been moved over 5. That's up 5, so my vertex is at 5, 5. So I know it's going to be 1/2 x is 5, because I know that it's right there, squared, plus 5, because my vertex has been moved 5 up. I didn't even need to plug it into the formula. I can just deduce that because I know where my vertex is. And so what I'm going to do is I'm going to say, okay, that's a distance of 1, which would mean that I need a distance of 1. Actually, it's a little, yeah, no, it's good. So I'm going to have a point here and a point here, and I'm going to curve up through them. Boom, and there we go.